as we can see that the 1A is want to find the area of the region, and the area of the region can be uh, the region of the area of the region is a double integral of the dx dy one dx dy, and use the Green theorem. It can be changed into 1/2 times integral x dy minus y dx. And as the
and just multiply it by dt over t, and we can get these two lines. And after simplify it, we can get the answer. So the most important thing in this question is that we have to convert the double integral into a line integral, just using the Green theorem. And also we have to do dy dt, and also the dx dt, and also the dy dt, and we can convert it directly into this equation. So this process is the most important thing in this question. Okay, let's and the answer is 2 pi. And let's move to the 1b. For 1b, this question is pretty hard because it asks us to find the center of mass. For this question, we have to use the equation or the theorem of center of mass. For the equation, I just write it down here. For the center of mass, because it's just an area with a slice of area, so we just have to find the center of mass on x, and the center of mass on x is just the double integral x, and the density depends on x and okay. My teammate will write down the equation on the blackboard. After we know the equation, we just have to solve the integration problem. Firstly, we have to solve the first problem is that what is this the density? How to the question gives us that the density is equal to absolute value of 1 plus y. When we see the absolute value, we have to be very careful that because we have to convert it back into two equations. What is that mean is because we have to also use the Green theorem to convert it, which means we have to find this. For this case, we have two equations. The first case is equal to 1 minus y. The second case is equal to negative 1 plus y. For these two cases, we can write down the first f1, is equal to x when y is larger than -1, and for y less than -1 it is minus x, and for f2 we can also do the separate case. For y larger and equal to -1, it is minus half y squared, and for y less than -1, f2 is equal to 2 half y squared.
Why don't you just write over the board?
Oh, okay.
Nothing's clear. We have only 2 minutes left.
Okay. So we just consider what is the f1 and s2 can result in this 1 plus y, and the results may be one of the possibilities is that y f2 is equal to, when y is larger than -1 and when y less than 1 is x and minus x, and also for this f1. For f2, we also have the separate case. When y is larger than equal to -1, x is half y squared, and also negative half y squared for y is less than 1. For these cases, we now have to do the integral of this. So we just write down this. And use a green drawing to convert it into an integral. We can get that. However, the density has the extra value. We have to divide it into 2 cases. The first case is into when t equal to 0, integrate when t equal to 0 to until y is less than 0. And how to calculate that is that we have to find it when y is less than -1, and because the question has given us the equation that y is equal to 2 sin t, we have to solve this equation. However, this equation, how to calculate this result is that we used to use the numerical method. We will not show here, and the answer is that t is approach 3.4. So we now get a t. We get back here and integrate until t is equal to 3.4, and we just write down the f2, the cases on there, and it should be negative half y squared, and y squared is equal to this one, and we just write it down here. another case is integral 4t is equal to 3.4 to 2 pi. And now you just integral this equation and all of you can get the result. And the step is very complicated. I will not show here. Thank you for listening.